Hello guys. I welcome you to our electrical engineering technology lesson. Our topic being electric fields. So to go through our topic, we've got a set of objectives, which I believe by the end of the presentation, we will be have done justice to our topic. But this PowerPoint presentation only touches on definitions. So we should be able to define what is an electric field strength, electric flux density, permittivity of free space, relative permittivity, capacity, and capacitance. Those are key definitions which we are expected to know. We should be able to explain what is an electric field strength and the formulas that relate to the electric field strength. So, and the units for electric field strength. So, before we go into the definition, we should have an appreciation of what is termed an electric field. So, an electric field is a physical field that surrounds electrically charged particles. So when we have got particles with different potential, consider the place of a capacitor. One is positively charged and the other one is negatively charged. The field between those plates is what is known as an electrical field. So in our introduction on that picture there we've got plate A and plate B, plate A being positively charged and plate B being negatively charged. So those plates have got different potentials and the field between is what we know is also known as the electrostatic field or the electric field. So at the diploma level, we are going to look at different types of capacitor, not necessarily parallel plates capacitors. We are also going to look at concentric cables. For example, a coaxial cable is a concentric cable where the inner cable or the inner conductor is considered as one plate and the outer shield is considered as another plate. So the plates of a coaxial cable are considered as plates of a capacitor. We're also going to look at twin isolated lines, like the two pair cable is another form of a capacitor. So you should also know how to deduce the capacity of the capacitance of such a material. So the first definition is the electric field strength. So an electric field strength is denoted by the capital letter E, that's the symbol for electric field strength. So when we have two parallel plates with a different potential and they are separated by the distance d, and the distance is measured in meters. So the electric field strength can be defined is the potential difference divided by the distance between the plates. So the units is volts per meter because we are dividing voltage with distance. So that's the definition for electric field strength. We now move on to another definition, which is electric flux. So electric flux is denoted by a Greek letter phi. So electric flux is a property of an electric field. It can be defined as the number of forces that intersect a given area. So the field lines are also known as the flux lines. So it can be defined as the magnitude of an electric field and the surface area perpendicular to that field. So that illustration represent the field lines and the surface area. So we said electric field strength is voltage over distance. Then if we multiply by area, which is so the units is voltage over meters multiplied by meter squared, we get voltmeters as the units for flux. So that is it about flux, and we move on to another definition, which is electric flux density. Electric flux density is the measure of electric flux passing at right angles through a unit area. So electric flux density is denoted by capital letter D, and it's charge over area. So the units of charge is coulombs, and the unit of area is meter square. So the units for electric flux density is coulombs per meter square. Then another parameter which is important in the study of electric fields is permittivity of free space. So at any point in the electric field, the electric field strength denoted by E maintains an electric flux, and it produces a value of electric flux density at that point. So for a field established in vacuum, the value of electric flux density to the electric field strength is termed E naught, or permittivity of free space. So the ratio is of electric flux density to the electric field strength in vacuum. That's the permittivity of free space. So scientists have discovered that that value is a constant. It's 8.85 times 10 to the power negative 12 farads per meter. So in capacitors, we've got insulating material. So relative permittivity is denoted by epsilon r, and it's the flux density in the material divided by the density in vacuum. In the order of for free space, the flux density in free space is equals to flux density term. So relative permittivity in free space is equal to unit. Then another parameter we are going to look at is capacitance. That is the property of a capacitor to store an electric charge when its plates are subjected to different potentials. So that is what is known as the capacitance of a capacitor. It is measured in farads, and the farad is denoted by the capital letter F. So in other terms, we can say capacitance C is equals to charge over voltage. So that is it on definitions. So on your own, you should master the formulas for calculating the capacitance of a parallel plate capacitor, the formula for calculating the capacitance of a concentric cable, and the capacitance of a twin isolated line. I thank you.